Hello friends, hope you are having a fantastic day today. So once again, today we are going to solve a very popular LeetCode problem. So without any delay, let's get started. So the LeetCode problem we are going to solve today is called Palindrome Linked List. And this is a LeetCode easy problem and also extremely well-liked problem on LeetCode. Problem statement is very simple. We are given the head of a single linked list and we need to check that if this given linked list is palindrome or not. If it is palindrome, we need to return true. If it is not palindrome, we need to return false. So this is one of the examples where we are only given the head of this linked list and then we need to iterate over all of these values. After iterating over, we need to essentially determine that whether this is a palindrome or not. So in this case, we can see that since this first two portion and last two portion are same in the reverse order, it is a palindrome. So in this case, we will need to return true. Suppose we were given a linked list like this, where values are 1, 2, and then once again 3. So in this case, this is not a palindrome, but in this scenario, instead of this being 3, if we had value as 1, then this would have become a palindrome and we need to return this one. So the problem statement is very simple to understand, but there are a couple of nuances with this problem. So number one problem is that we are only given singly linked list. That is one part. Second thing is we don't know that how many number of total values are inside the given linked list because we are only given the head of the linked list. So that is the second problem. Third problem is that in order to determine that whether anything is a palindrome or not, we essentially need to break this existing linked list into two portions and determine that whether it satisfies the property of a palindrome or not. So if it is an even numbered palindrome or even numbered linked list, then both the halves would be of the same value. If it is odd number, then either this middle value could be shared or we can create a palindrome or compare just these two sizes of the palindrome. But in either case, we will need to find the middle pointer for each of the odd or even number of cases and then compare the first half with the second half. So this is going to be our approach towards the solution. Number one thing we are going to do is to find the middle of the existing singly linked list. Second thing is that we are going to compare two portions, the first part and the second part, and then we are going to come up with the solution. So first let's determine that how can we define or find the middle of any singly linked list. For that we have a very simple method, that is to use the two pointers, and first pointer is going to be a fast pointer and second pointer is going to be a slow pointer. The logic is quite simple, that at every single iteration, slow pointer is going to go to its next element and fast pointer is going to go to the next of the next element. So which means that fast pointer is going to make two hops and slow pointer is going to make one hop. The moment we identify that fast pointer has reached to the end of the list or fast.next value is at the end of the list, then whatever the position of slow pointer is has to be the middle pointer of any linked list. So let's see this theory in action. First of all, suppose we are given a linked list with let's assume 5 values for now, and currently these values are just simple sequential order, right? This is not a palindrome, we can clearly see that, but we are trying to find the middle point. So we are going to have two pointers, fast and slow pointer. Both are going to initially start at the very first position. So during the first round of iteration, okay, so fast and slow are at the starting at the same position. During the first round of iteration, fast pointer is going to make two jumps, so fast pointer would end up over here. Meanwhile, slow pointer would only make one jump, so slow pointer would end up at the second location. In the next iteration, once again fast pointer is going to reach to the very end of the linked list, or in this case because it will reach to the fifth position. Meanwhile, slow pointer would once again end up after just one single iteration over here. Now notice that currently fast.next is actually the null value or the end of the linked list, which means currently this fast pointer is at the very last element of our existing linked list. So whatever the position of slow pointer is has to be the middle pointer. And in this case, based on the number of hops we take from starting to end, we can determine that whether this value is odd value linked list or even value linked list. And based on that, we can determine that which middle portion we will need to check. So now we have a linked list with 1, 2, 3, 4 and 5. We identify that this 3 is the middle pointer, which means in order to check that whether this is a palindrome or not, we will need to compare these two items and we will need to compare these two items. That is number one option. So what are the ways for us to do that? Now, number one thing is that let's say that if this were to be a palindrome, let's assume that instead of this being 4 and 5, suppose these values were 2 and 1. If this was a correct palindrome, the approach would be when we compare the first and second value, and when we go in the reverse order for second and first value, the value should have been same. So if we try to compare this value with this value, we should get the same result. If we compare this value with this value, once again we should get the same result, which means we are comparing in the reverse order. Now, which data structure allows us to fetch the last entered element at the very beginning? And the answer is quite simple, that is stack, because we know the logic of stack is that it works on the last in first out principle. And in this case, we only need to check that what was the last value we put in and what was the first value we put out, so we can start comparing these two values end to end and then come up with the simple solution. But this is not the optimal solution, but this is a way to get to the optimal solution. So the logic is that first what I'm suggesting is that we have an empty stack, and currently in the empty stack, whenever we are iterating over these values in sequential manner, because slow pointer is going to go through all of the values. Okay, so all the values that are currently placed in the slow pointer, we are also going to add it into the stack, and fast pointer is going to lead us to the very end of the linked list. And then once we find the middle portion, we will have this first portion of the linked list inside the stack, and our start pointer would be at the middle portion. So we will have a way to iterate over all the remaining values inside the existing linked list, and then we will simply pop one value out from the stack and compare that value with our linked list. So let me clean this up a bit and once again just re-explain the whole solution that I just suggested using the stack and linked list. So number one thing is, suppose our linked list is 1 2 3, and then let me add one more value. Okay, and then 3 2 1. Okay, suppose this is our linked list is like this, and currently our stack is empty. Now let's start iterating over using our two pointers. So if we do that, basically currently fast pointer is going to be here, slow pointer is going to be here. In the next iteration, fast pointer is going to end up over here, slow pointer is going to end up over here. In the next iteration, fast pointer is going to end up over here, meanwhile slow pointer is going to end up over here. And finally fast pointer, when it reaches to the end, slow pointer is going to reach to the value number 4. So far slow pointer has taken journey from 1 to 2 to 3 to 4, and it realized that this is the middle pointer. We also identify that this is an odd number linked list, which means this middle portion either we consider it 2 times or we don't consider it. So we have both the options, depending on whatever programmatical approach we wants to go, we can go with that. So our algorithm is that all the values inside the slow pointer, we are going to add it into the stack, and we are going to add it into the, once again based on the property of the stack, that is last in first out. So we are going to have value number 1, then value number 2, then value number 3, and in the end value number 4. Or we can, if you choose, you can also not have value number 4. So let's not have value number 4 for the simplicity's sake. Now our starting pointer is slow pointer is here, remaining portion we need to compare. So what we can do is, with every iteration we make on the slow pointer, we simply pop one value out of the stack. If both values are same, because logically if they are palindrome, then both values has to be the same. If both values tend to remain same and we reach to the end of the linked list, then we can say that this is a true palindromic linked list. So logically, once again in this case, so first we move to the next value, we find value number 3, we pop one value out, once again value number is 3. So because both are same, we can ignore these two. Now once again we move forward to the next case. So next value is value number 2. Once again when we pop out, we also get value number 2, which means this is also good. And in the end this is 1 and this is 1, so this is also good. We reach to the end of the linked list, which means this is a palindromic linked list. So we can return true in this case, that this given singly linked list is a palindrome, which is quite awesome. Now come back to our question and let's try to analyze the time and space complexity in this case. The time complexity is actually quite simple. It's simply big O of n, because notice our slow pointer is simply iterating over all the characters in order for us to determine that whether this is a palindrome or not. And this is the best we can do. We cannot go any faster than this. It has to be big O of n, because in order to check for palindrome, we will have to check every single node inside the linked list. But in order to check for the space complexity, now in this case, because we are using an extra space, our space complexity is going to be big O of n divided by 2, because we are only populating the stack up to the half pointer of any given linked list. So this logic would work fine and this solution would also work as expected. But let's think, is there a way we can improve upon this solution? And the answer is yes, quite simple. That is the improvement we can make on the space complexity. The question is, do we really need to check for the stack, or is there some other way we can actually avoid using the stack and still iterate over these values and compare these values whether they are same or not? So the answer is actually quite simple. The logic this time we are going to use is that we are actually going to use 2 pointers. So we already defined that we are going to be using 2 pointers to find the middle of the linked list. So let's assume that we find the middle of the linked list as the slow pointer. Now we have these values 1, 2 and 3 over here, and these values as 3, 2 and 1 in the reverse order. If that is the case, then only this is a palindrome. So what logic we are going to use is that at every given moment we will actually have to manipulate these nodes to point to in the reverse order when we are finding the middle pointer as well. And there is a very popular algorithm for that, that is reversing the linked list. In this case, we will actually have to manipulate this existing linked list for a bit. So how it would happen is that initially, suppose this is the linked list we are given. Now the moment we are trying to find the middle pointer, that is this slow pointer that is reaching to the middle pointer, we are actually going to manipulate our list. So currently the list is 1 is pointing towards 2, 2 is pointing towards 3, and then 3 is pointing towards our middle value. Let's assume this is 5, and then this is pointing towards 3, 2 and 1 in this fashion. So logically, when our slow pointer moves from 1 to 2, instead of like only updating, we are also going to update this 2 to point back to the 1 instead of pointing to the 3. This would be called, basically we are manipulating the input for our simplicity's purpose, because we are trying to optimize our solution in terms of space complexity. So now we are going to have a linked list that looks like this, where currently this is pointing towards this, then 3 is pointing towards this middle pointer 5, where currently our middle pointer rises, where our slow pointer is, and then 5 points back towards 3, and then once again 2, and then once again 1. And using this logic, we can actually traverse back and we can create a dummy node, and that dummy node we can point back from 5 to, let's assume that this is the dummy node D, and then this is the small pointer. So all we need to do is that we need to compare the small pointer with the dummy pointer values and then keep on going in the reverse order. And if both values remains the same, we can simply say that this is a palindrome. So how it would work is that, let me just clear this up a bit. And okay, so currently both at this location 5, we created a temporary node, that the temporary node points back towards 3. This is where our dummy node lies, and this is where our slow pointer lives. So dummy node dot next is going to be 3, and slow pointer dot next is also going to be 3. If both values are correct, we move to the next element. Once again, dummy node by dot next is going to be value number 2, and slow pointer dot next is also going to be value number 2. And same way, if we keep on iterating, eventually we would reach to the end of the list from this side and also end of the list from this side, and then we can determine that whether this is a palindrome or not. So this is the second approach. Now I know the second approach of using 2 pointers is actually an overkill. There are a lot of concerns, because the moment you would propose this solution, your interviewer is going to ask you that what if you cannot change the existing input. Then in this case, once this operation has been completed, you once again need to reverse the nodes to represent the linked list in the same fashion it was. That looks something like this. So there are a lot of overhead of operations in order to save in terms of space complexity. So both solutions are accepted and valid. The thing is, the stack solution has the space complexity of big O of n divided by 2, and the pointer solution that I just explained in the last, that contains the space complexity of big O of 1, but you are actually doing a lot of iterations back and forth, and you are also manipulating the given input string as well. So consider these two items, and now let's quickly see the coding solution. So in the code, I'm showing the solution for the 2-pointer approach, but if you want, I can also show you the coding solution for the stacks. So let me know in the comments if you want to see that. So here is the Java code for the solution we just explained. So first of all, we are going to check for the edge case that if the given input is null, we can simply return true. If that is not the case, first we will try to find the middle of the linked list using the slow pointer and the fast pointer. Once we do that, now we are going to start reversing the second half of the list using the reverse function for slow.next. And then we are simply going to compare the first half with the second half. And once the comparison is done, we simply need to check at any given moment that if the moment we identify that the values are not matching with each other, we can simply return false. If that is not the case, we can simply return true if we at any given moment reaches to the end of the list. And this is the whole solution. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Okay, so our code runs extremely fast compared to a lot of other solutions.